Okay, in this lesson, we are going to finish up with our congruent triangle proofs. And we're going to be looking at this time, not proving that two triangles are congruent, but proving that maybe they're two angles or two line segments in those triangles are congruent. When doing that, we are still going to use our side angle, side, and things. But we're also going to use a new acronym, and it's CPCTC. And that stands for corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. So if I know that my two triangles are congruent to each other, I know that all 6 corresponding parts are also congruent. All 3 corresponding angles are congruent to each other, and the 3 sets of corresponding sides are congruent to each other. So in these proofs, we're going to be asked to prove that parts of the triangles are congruent, such as 2 angles are congruent or 2 sides are congruent. So in order for us to prove that the angles or the line segments are congruent, we first have to, in our proof, prove that the triangles are congruent. Once we state that the triangles are congruent, then we can state that the corresponding parts, like the 2 angles or the 2 sides, are congruent. So let's look at some proofs together. So if you look at what you're trying to prove here, we are not trying to prove that the 2 triangles are congruent. We are trying to prove that 2 angles are congruent, not 2 triangles. So since I'm trying to prove that the parts, the angles are congruent, I have to go through and show that the triangles are congruent. To show that the 2 triangles are congruent, we've got to use side angle, side, and those 5 things like we've been doing. So to start this, again, we start with our given information. So I'm going to start with that AB is congruent to AD. And again, that was given. And just like before, we're going to mark our picture. AB and AD are congruent. Another set, BC is congruent to CD. Again, that was given. I'm going to mark it. It's my second set of sides, so they're going to get 2 dash marks. So now I need to try to prove these 2 triangles congruent. In order to do that, it's just like before. I have to show it by one of the 5 congruence theorems. So I have 2 sets of sides. These 2 triangles share that third side, so I know that it's congruent to itself. So therefore, AC is congruent to AC by the reflexive property. And then now I can say that my 2 triangles are congruent because I have enough information. So I've got to state that triangle ABC is congruent to triangle ADC by which of the conjectures or theorems? Side. Now that I have shown my triangles congruent, I can now show my parts that I'm trying to prove congruent. So now angle BCA is going to be congruent to angle DCA by, if I know my triangles are congruent, and I just showed that, I know that my angles are congruent by this acronym CPCTC. So that's going to be my last reason. So whenever you're finding angles congruent in the triangles or side lengths congruent in the triangles, your last thing is going to be the acronym CPCTC. Okay, let's look at number 2. Okay, on number 2, we have to look at what do we know here? We know, first of all, our given is that PS is parallel to QR. That's given. We already said parallel lines tell us something that angles are congruent. But I'm going to go ahead and put my other piece of given. Angle QPS is congruent to angle SRQ. Again, that's given, and I'm going to write or mark it. QPS is this angle, is congruent to SRQ, this angle. Okay, again, parallel lines show us congruent angles. So I'm going to highlight here PS and QR are my parallel lines. They have a transversal, which is this SQ that goes through them. Therefore, I have some angles congruent. I have angle PQS would then be congruent to angle RSQ. And the reason they would be congruent, parallel lines cut by a transversal, so these are alternate interior angles. Got to know those angle relationships. Okay, so if I look, I have two sets of angles that are congruent. I still need one more piece of information. These two triangles share QS, so that side is congruent to itself. So QS is congruent to QS by the reflexive property. Now, before I can show that the two sides are congruent, I have to prove that the two triangles are congruent. And I have enough information, so I can say that triangle PQS is congruent to triangle RSQ by, if I look, angle, angle, side. And now that I've proved the two triangles congruent, I have enough information now to say that PQ is congruent to RS by our acronym, corresponding parts of congruent triangles are congruent, or CPCTC. Okay, let's look at number 3. On number 3, we start with what's given. X is the midpoint of WY, and VZ, that is given. Well, if X is the midpoint, that tells me that some side lengths are congruent. So if X is the midpoint of WY, here's WY, that means it's cut it into two equal parts. So WX is then congruent to the other half, XY, by definition of midpoint. X is also the midpoint of another line, VZ, which means it cuts it into two equal parts. So VX would then be congruent to XZ by, again, the definition of midpoint. And before I go any further, I need to mark these things. So WX and XY, VX and XZ. And then I need one more set of information before I can prove these two triangles congruent. If I look at my triangle, I have vertical angles here. So I can say that angle WXV is congruent to angle YXZ by the vertical angles. I now have enough information to prove these triangles congruent. Again, I have to prove the triangles congruent before I can prove the angles. So triangle, I can say WVX is congruent to triangle YXZ. If we look, we have side, angle, side. Now that the two triangles are congruent, I can prove that everything else in it is congruent, or corresponding things are congruent to each other. So angle XWV would then be congruent to angle XYZ by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, you pause the video and you try number 4 and 5.